Hi students, today we are going to study about semi-solid dosage forms. So first, definition of semi-solid dosage forms. What is semi-solid dosage forms? From the name itself, it is known that semi-solid, we already know it is not a solid dosage form, it is not a liquid dosage form. We know already solid dosage forms like tablet, capsule, etc. and liquid dosage forms such as suspensions, emulsions, then monophasic liquid dosage forms such as syrup, lotions, etc. So semi-solid is something which lies between liquid and solid. So in case of semi-solid dosage forms, the examples are cream, ointments, paste, gels. These are the examples for semi-solid dosage forms. So let us see the definition of semi-solid dosage forms. Semi-solid dosage forms are dermatological preparations. Dermatological means skin, which is applying on the skin. Intended to apply externally on the skin to produce local effect or systemic effect. We already knows what is local. Local means what on the above the skin, and systemic also you knows. Example: ointments, creams, gels and paste. They contain one or more active ingredients dissolved or uniformly dispersed in a suitable base and any suitable excipients such as emulsifiers, viscosity increasing agents, antimicrobial agents, antioxidants, stabilizing agents. So what it explains, these are prepared by, we will add the API. Active ingredients means API, that is the medicament. So that medicament will be mixed with the suitable base. We already know what is a base. And we also use emulsifiers. We use viscosity increasing agents, antimicrobial agents for preservative property, antioxidants to prevent oxidation, or stabilizing agents. So these characters which improve the quality of the medicament might be physical character, chemical characters and therapeutic characters. Okay. Semi-solids can adhere to the application surface for sufficiently long periods before they are washed off. Means what? We will apply the ointments or gels or paste to the skin and that will remain on the skin for longer time. So when it remain on the skin for longer time, what is the advantage? It will give good therapeutic action. So next line explains that this property helps prolong drug delivery at the application site. Novel semi-solids are non-greasy. Novel means what? New. New trend means latest, which is the semi-solid dosage forms of this period. New ones. Okay, latest semi-solid dosage forms are non-greasy. So what do you mean by non-greasy and what is the advantage of non-greasy? Non-greasy means it will not irritate the skin. Irritate in the sense, greasy means what? When greasy type applied to our skin, we will feel little like it will be like sticking on the hands and all. Okay, but non-greasy means it is easily washable. With water we can wash and remove. Hence they cause less irritation to the skin and are superior to conventional semi-solid dosage form. Conventional means that old type which we are following from the olden period. So when we compare the novel semi-solid dosage form, novel means what? New, latest. So it is superior. Superior means what? It having more advantage compared to the semi-solid dosage form of conventional period. Means which the one. Conventional means the old one which are practicing. Okay. Next is classification. Semi-solid dosage forms can be classified as ointments, creams, paste and jellies. First one is ointments. Ointments are soft semi-solid preparation meant for external application to skin or mucous membrane. They usually contains medicament which is either dissolved or suspended in the base. We already studied or we already know that this medicament which will be dissolved in a particular base. They have emollient and protective action. What do you mean by emollient? Emollient means it will make the skin soften, softening of the skin, or it gives a soothing effect. Next is creams. Creams are semi-solid emulsions and are generally of softer consistency and lighter than ointments. So creams means they are also semi-solid and they are generally of softer consistency and lighter than ointments. They are less greasy and are easy to apply. So we already studied what you mean by greasy and non-greasy. So less greasy, so it can be easily washable. So as it is less easy, it will be easy to apply also. Next is paste. Paste are semi-solid preparations for external preparation that differ from similar products in containing a high proportion of finely powdered medicaments. So paste will contain high proportion of finely powdered medicaments. And paste compared to other semi-solid preparations, paste are a little bit stiff. Stiff means are a little bit hard compared to the other semi-solid preparations. And the function of paste is it gives a protective action. And it also have the ability to absorb serous discharge from skin lesion. What do you mean by serous discharge? Serous discharge means that yellow color fluid which is coming from the wound and all. That is known as serous discharge. So lesion means wound. That is skin lesion means it's a wound in the or injury in the skin. Okay, from there the yellow fluid will come. So that paste is having a ability to absorb the serous discharge, that yellow fluid. So it gives a protective action. So if we require a protective action, the pharmacist will use what? Paste. But if we require a therapeutic action, then we will prefer ointments and creams. Next is jellies. Jellies are transparent or translucent, non-greasy, semi-solid preparation mainly used externally. The gelling agent may be gelatin, starch, tragacanth, sodium alginate or cellulose derivative. So what are jellies? Jellies are transparent or translucent. That are the physical characters of jellies. It is non-greasy, semi-solid preparation. And gelling agent, what do you mean by gelling agent? The agent which helps to create the jelly form. They are gelatin, starch, tragacanth, sodium alginate or cellulose derivatives. Example, carboxymethyl cellulose is an example for cellulose derivative. Next, we will study about physiological and pathological conditions of skin. It comes under factors affecting dermal penetration. First is physiological and pathological condition of skin, and second we will study physicochemical properties of active substance or the medicaments. So there will be two classifications under factors affecting dermal penetration. The first point is reservoir effect of the horny layer. What do you mean by horny layer? That layer of our skin. Okay, so this classification explains about the how when the character of the skin changes or the physical characters or condition of the skin changes, how the penetration of the semi-solid dosage form varies or changes. Okay, so in that first one is reservoir effect of the horny layer. The horny layer is thickest on palm and sole and thinnest on the face. So penetration rate increases with the decreased thickness of horny layers. If horny layer thickness is less, then penetration will be more. Next is skin condition. That means the condition may be due to age or disease or climate or injury. So see the example, absorption occurs rapidly in children. Why? Because children's skin are very soft, and if the dermis is exposed by wound or burn. So if a dermis is exposed to wound or burn, what is the thing? There will be lesion, wound, like tissue, skin will be opened. So through that, the absorption will be more into the systemic circulation. Next is skin hydration. The hydration means what? Moisturizing. Okay, there will be the presence of water. The hydration of keratinized cells is raised by covering the area with the moisture-proof plastic film to prevent evaporation of perspiration. Hydration increases the drug penetration. So if the skin is hydrated, then the rate of drug penetration or permeation into the skin will be more. So next we are going to study the factor skin age. So we already learned about the skin, means when the skin is young, then in case of children, the absorption will be more. And next is blood flow. Blood flow change in peripheral circulation. That other than the circulation in the heart, the other circulations are known as peripheral circulation. So depending upon the change in peripheral circulation, the transdermal absorption or the permeation of drug to the skin also varies. Next is skin temperature and pH. That means when there is variation in temperature, it can affect the permeation of drugs. Like that, in case of weak acids and weak bases, how it dissociates, it depends upon the pK and pKb values. What do you mean by pKa and pKb? That is the acid dissociation constant of a solution. pKa determines acid and pKb it estimates the how strong is the alkaline. So if pK is lower, then it will be a strong acid, and pKb is lower, that means it is mostly alkaline. Okay. Next is regional skin site, species variation and skin metabolism. In regional skin site species variation, it mostly explains about the physical characters of the skin. As the physical characters change from species to species or person to person, the permeation of the drug also depends on that. It will be different. Next is skin metabolism. Skin metabolism means what? It is a biological process that occurs amongst the epidermal and dermal cells to regulate the rate of cell turnover, collagen production, and repair any damage which is caused due to UV light. So that the metabolism happening in the skin. So skin metabolizes steroids, hormones, chemical carcinogens, and some drugs. So depends on the skin metabolism. The drug permeation also differs. Next is physico-chemical properties of active substance, so in the semi-solid dosage forms. First one, molecular characteristic of drug. In this, it depends or explains the molecular weight. So depends on the molecular weight, the permeation differs. That is, molecular weight up to 400 daltons can easily permeate through the skin surface. Next is drug concentration. The flux is proportional to the concentration gradient across the barrier, and concentration gradient will be higher if the concentration of drug will be more across the barrier. Next is solubility and partition coefficient. Highly lipid soluble molecules. So in our skin, we already know that we have a skin which is having a lipid layer, right? So the drug which is mostly lipid soluble, that will enter fast through the hair follicles. Moderately lipid soluble molecules penetrates directly across the horny layer. Next is crystal structure or polymorphism. The metastable polymorph is much more soluble than its stable form. So the release of drug in metastable state is much more faster than stable form. So depending upon the characteristics of or the crystal structure or polymorphism of the drug, the permeation of the drug varies. So the metastable state is more, it will release faster as compared to the stable form. Next is dissociation constant or pK. That we have already discussed. If a drug is ionized in the surrounding pH of the dermis, then the penetration of the ionic species are restricted by electrostatic interactions or electric charges. Degree of ionization depends on the pKa of the drug. Example, methyl salicylate and methyl nicotinate penetrate much faster than salicylic acid and nicotinic acid respectively. Next is partition coefficient. The optimal partition coefficient, denoted by K, is required for good action. Drugs with higher partition coefficient are not ready to leave the lipid portion of the skin. Also, drugs with lower partition coefficient will not be permeated. That means the optimal partition coefficient is required for what? For the penetration of drugs. The drugs with higher partition coefficient are not ready to leave it will not leave the lipid portion of the skin, and the drug with low partition coefficient will not be permeated. So higher one will not leave the lipid portion of the skin, and the lower one, what is the issue? It will not permeate. Next one, diffusion coefficient. Penetration of drug depends on diffusion coefficient of drug. At a constant temperature, the diffusion coefficient of drug depends on properties of drug, diffusion medium, and interaction between them. So diffusion coefficient is one of the important factor. When there is a constant temperature, we see in that skin temperature and pH. So when the temperature of skin is a constant, then the diffusion coefficient depends on the other factors like which drug it is, whether the drug is lipid soluble, the characteristics of drug, then diffusion medium, then and the interaction between diffusion medium and drug.